Assalamualaikum. So before this, I have told you how to find the magnitude of the magnetic force, right? So the magnitude of the magnetic force is given by F equals to Q VB sine theta, where theta is the angle between velocity and magnetic field. Now, here I am going to explain to you how to find the direction of magnetic force, right? So the direction of magnetic force, okay, can be determined by using right hand rule number 1. Okay, so we are going to use our right hand. Okay, I have drawn here. So this is our thumb. Okay, this is our four fingers and this is the palm. Right. So the thumb will show us the direction of the velocity. The four fingers here will direct us to the direction of magnetic field, and the palm will give us the direction of the magnetic force. Alright, so like this, here we have, here is the direction of the velocity. The four fingers will show us the direction of the magnetic force, and the palm will show us the direction of the magnetic force. Okay. In this video, I am going to explain to you further the direction of magnetic field. Alright, the direction of magnetic field can be expressed in terms of the direction of compass that are north, east, south, and west. Alright, now recall back the right hand rule number 1 that I have explained to you in the previous video. Okay, if I make my hand like this, it means that the particle is traveling towards westward and the direction of the magnetic field is northward. Therefore, the particle will experience magnetic force that is directed downward. Right? In the other hand, if the particle is negatively charged, it will be that the magnetic force experienced by it will be upward. Alright, if I make my hand like this, it shows that, okay, the particle is traveling towards eastward and the magnetic field is directed northward. So therefore, the particle will experience magnetic force upward. Okay. Similarly, if the particle is electron, then it will experience magnetic force downward. Alright. Further exercise. An electron moving due west in a region of magnetic field which is directed northward. Find the direction of magnetic force on the electron. Alright, so the electron is moving due west, meaning your thumb must be directed to the left. Okay, and the magnetic field is directed northward. Alright, so meaning your four fingers must be directed along the direction to the north. So what is the direction of the magnetic force on the electron? It will be upward, isn't it? Because it is an electron. Okay, if you say downward, it refers to proton. Okay, so for electron, it will be reverse direction. Okay, in the opposite direction, that is will be upward. Direction of magnetic field also can be expressed in terms of x, y, and z axis. Okay, now let me show to you. If the direction of magnetic field is along y axis, then we can say that it is directed northward. If it is in the direction along negative y axis, it is southward. Okay, if the direction of magnetic field is directed along x axis, we can say it is directed eastward or to the right. If the direction of magnetic field is directed to the left, it means it is directed westward or to the left, right? And the other one, if the direction of magnetic field is along z-axis, if it is out of the page, then we can say it is positive z. If it is into the page, it is along negative z. Now let me show to you. Alright, so let's say this is the page. Alright, what we mean by positive z and negative z is that if positive z means the direction of the magnetic field is like this. Okay, if the direction of magnetic field is negative z, then it will be into the page, inside. Okay, inside. Okay, all right. Positive Z, okay, the direction of magnetic field along positive Z, okay, can be represented by symbol like I have drawn here. Okay, if the direction of magnetic field is along negative Z, then it can be expressed by this symbol, the cross, right? Now, more example on the direction of magnetic field. All right. So look at these examples. Okay. So if we have a particle, if we have a charge, let's say a proton. Okay, a proton that is traveling. Okay, along this direction. Okay, V. Right. So by using right hand rule number 1. So first we identify the direction of the velocity. That is the direction of our thumb. Okay, northward. Okay, northward. And the direction of magnetic field is into the pitch. So your 4 fingers must be directed into the pitch. Alright. So where is your palm directed to? Your palm is directed to the left. Alright. So it means that this particle will experience magnetic force to the left. Example. Okay, here you have the direction of magnetic field is along positive x, okay, and the direction of, okay, this, let's say this is a proton. Let's say the proton is traveling northward. Okay, so you have traveling northward, and the direction of magnetic field, your 4 fingers must be directed to the right. So where is your palm directed to? Your palm is directed downward. Alright, downward or into the pitch. Right, so you can write it like this. So the force will be into the pitch. Alright. Okay. And if the particle is electron, so we can say that it will experience magnetic force out of the pitch. Alright. Okay, last example. Here you have the direction of the velocity of the particle is out of the pitch. And bear in mind, in this example, the direction of magnetic field is to be determined. Here you have the direction of the force that is directed to the north, meaning your palm must be directed to the north. Okay, your palm must be directed to the north, right? So the velocity is out of the pitch. Okay, out of the pitch. So it's out of the pitch, all right? Automatically, your palm is directed to the, automatically your 4 fingers is directed to the right. So you have like this. Okay, so this will be your this will be the direction of your magnetic field.